All right, so now that we have a nice sketch of our graph on our notes with some important points labeled, let's see if we can answer some of the questions. Part B says, on what intervals is f negative? So I have to remember, when I say negative, I mean when is this graph below the x-axis? When are those y values negative? On this graph, that happens in this section right here. So you'll notice that it goes from one x-intercept to the other x-intercept. And when we write our intervals, we always use the x values. So I'm just going to use the x values between those two x-intercepts. So it's negative between negative 0.562 and 3.562. The next question is, on what intervals is f decreasing? So remember, when we're looking at increase and decrease, oh my goodness, I knew that was going to happen. When we look at intervals of increase and decrease, we follow the graph from left to right with our eyes. So when I do that, I notice that my graph goes down, 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 up, 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 up. So it's decreasing everywhere on this left side of the graph until it reaches my vertex. So it's decreasing from the x values, negative infinity, all the way over here to the left to this x value of 1.5. Part D says, give the value of the relative minimum and the value where it occurs. My relative minimum is this vertex point. The relative minimum is the y value, negative 4.25, and that happens when x equals 1.5. For part E, evaluate f of 4, and part D, determine the x values for which f of x equals 7, we'll need our graphing calculator again. So part E, evaluate f of 4. Remember, that's asking me when x equals 4, what does the y value equal? So I'm going to go back to my graphing calculator. I can do this one of two ways. I can either hit second trace, and then you see how number 1 says value? I can hit enter there, and the x equals pops up. Again, I know that x equals 4, so I type in 4, hit enter, and I get that y equals 2. Additionally, I can go to my table, which it happens when I hit second graph, and I can see on the table that when x equals 4, y equals 2. So I would write that f of 4 equals 2. For part F, determine the values of x for which f of x equals 7. That's saying when y equals 7, what does x equal? So if I go back to my calculator and I look at this table, I notice that there's no 7 in this y column, which means I'm going to have to use a different strategy. So I'll go to my y equals because I know that the y value is 7 on this function. So I'll type in a 7 for y2. Then I'll hit graph. I notice my parabola still, but now I notice this straight across line at y equals 7, and my job is to find these 2 points of intersection. To do that, I hit second trace. Number 5 says intersect, and again I see my blinky dot. So I'm going to move that blinky dot to the first point of intersection, or as close as I can get to it. And this time it's really easy. We just hit enter 3 times. Enter, enter, enter. And I get that for my first intersection, when y equals 7, the x value is negative 1.854. I have another point of intersection, so I'm going to do this one more time. Second trace. Number 5 says intersect, and I just move my blinky dot using the left and right arrows on my calculator to that other point of intersection. And make sure I'm on it, and I hit enter 3 times. And I get that the other point of intersection when y equals 7 is the x value 4.854. All right, and the last piece of this example is end behavior. Remember, with end behavior, we want to use our good limit notation and write it exactly the same way every time. So first, the limit as x approaches infinity of f of x. And second, the limit as x approaches negative infinity of f of x. So for this first one, I'm asking myself, as the x values get really big, what's happening to the function? So I look at my graph, As my eyes continue to go to the right, as the x's get super big, my eyes also are moving up, which means that the function itself is going to positive infinity. For the other one, as the x's continue to get very, very small, my eyes also go up, which means that on the other side of the graph, that limit is also approaching positive infinity.